So welcome you all in this new video, and today video is going to be very interesting, that is about quantum computing. Okay, see, in this time we are seeing that how quantum computing is increasing in our daily life day by day. And you have seen that recent news that there was a supercomputer, okay, that was based on quantum mechanics. Okay, quantum computer, you can say, that was named Willow, okay, by the Google. It was developed by the Google, okay. And what is the speciality of this Willow quantum computer that was developed by the Google? Okay, it can solve the complex to complex problems, okay, within the 5 minutes or less than with this time, okay. And if you give the same complex problem which was solved by the this quantum computer which was made by the Google Willow, okay, in the 5 minutes, and if you give this complex problem, same complex problem, to the super, you can say, computer, okay, that is based on the classical physics, okay. So this supercomputer would have taken the trillions to trillions years, okay. You can say the supercomputer which we see today, okay, that were based mainly on the classical physics, okay. Classical physics would take around the trillions year to solve the same problem. That problem is solved by the quantum computer within just seconds, okay. Can you imagine how much fast is the quantum technology is, quantum, you can say, computing is. And now the question arises that what is the difference, if for a very low man person I have to say that this is a classical physics or this is the quantum physics, okay, and the person will not understand the things because he will say that computer works on the electricity, okay, and there is some instrument made inside and that works properly. But guys, see, there is much more difference that classical and quantum mechanics. Let me tell you the initial fundamental difference what it is, okay. In the classical physics, okay, in the classical computing, that you used fundamental units which are here, okay, that are 0 and 1, okay. And here fundamental units are same, okay, but they are in different kind of range. For example, you can take it like this, okay, like this, and take it like this. So this is a needle, okay, this is 0 and this is 1, and this is the case, you can say, quantum, okay, and this is the classical. For example, let me tell you, simply I can say, okay, uh, how many outcomes you can possible outcomes you can get here in classical computers, okay, that is only two. Means that whatever information and whatever the calculations and whatever processing will be done in the classical computers, that will be done only in these forms 0 and 1, only these two form. They will exist separately, okay, they will exist 0, either 0 or 1, either 0 or 1, either 0 or 1, okay. In this way, you know that our classical computing and all the computers which are based on this classical computing, okay, they store the information, process the information, transfer the information in this binary numbers, okay. And the thing is here that the binary number is only like 0 1 0 1, for example. Means that there cannot be exist state like this 0 1 or 1 1 0 1, okay, or 1 0. This state will not exist here. Here will be only two states, okay, only in the bits. These are called bits, okay, bits. So you need larger kind of this thing, okay. See, you have the, let's say, mathematics problem, okay, let's say x. And if you want to solve this mathematics problem x through the classical computer, okay, classical computer will solve this with the help of this information, okay, 0 1 0 1 0 1. It will not work simultaneously, and this is the thing, okay. You just understand simply this, that classical computer will work on the bits, and bits will be the 0 and 1, okay. There will not be any state that exists between the 0 or 1, okay. That's the case of classical computers. You will understand this thing betterly when I will explain you how the quantum computer works and how the qubits works, okay. So now let's take the example of quantum computers, okay. quantum computers. See, in quantum computers, as I told you, that this is the, and this is the range. Okay, you can say this 0 and 1. Okay, in this range, like in classical computer, you will get the information only 0 and 1. Okay, which is very limited and very time taking. But when you get all the information, whatever comes in the range between the 1 and 0, and also here the states will be 1 0 0 1 1 1, whatever exists between that, it means that it covers the largest informations, or you can say it can provide you the many states. For example, if any information is here between that, okay, and quantum computer is providing you this all data, 1 or 0 or 1 condition, it is providing definitely, but it is providing you all the informations, all the states, and all the information it also acquire between this. Okay, you can say that quantum computers works on the fundamental similarly to the bits, but there are range. Okay, it can vary from the 0 to 1, 1 to 0, or it can exist in any states. Okay, so here quantum computers, here is not the limitations of the states only 0 and 1. Okay, it can exist in any numbers between 0 and 1 also. Okay, so I think it was a little bit difficult for you to understand, but let me make it more simple. Okay, that why quantum computer quantum computers are increasing day by day, and their capacity is so high. Okay, capacity is very high, and speed is also exponentially, you can say, unparallelable with the uh, this normal supercomputer that we see. You can get this thing by looking at this. Okay, the recent quantum computer which was developed by the Google, okay, below, its capacity is such that it can solve the same classical or complex problem of the mathematics, or any complex to complex problem within the 5 minutes. To solve that same problem, a supercomputer which worked on the classical mechanics or classical physics would have taken the trillions years. You can say that for the same work, for which the classical computer is taking about the trillions year, the same work is done by the quantum computer within the 5 minutes, or within the minutes, or within the seconds. You can just imagine what is the speed of these quantum computers. Okay, so now understand that what is that, yeah, what is the thing that make it so special, and what is the fundamental principle. These are the normal principles that we studied in the quantum mechanics. Okay, but how beautifully they all are used in the quantum computers, that's a very interesting thing, and that's a very beautiful thing in quantum mechanics. Okay, see, it works on the superposition. Now you will say that what is this superposition, and see guys, it works on the two principles, superposition and entanglement. Okay, but I have to see, this is superposition, and second is quantum entanglement. Okay, quantum entanglement and superpositions are the two basic principle upon which whole quantum computing works. Okay, and it is very interesting, guys. See, uh, let me tell you. First principle is superposition. You just be conscious and listen carefully whatever I'm saying. Okay, you will get this principle very clearly, and even you will feel it very interesting. Okay, at the end of this video, see, superposition is what? Superposition, if I simply have to tell you, that a quantum computer can measure the different states of a particular thing simultaneously. Okay, means what? Now question will arise, means what? Let me give this through an example. Okay, okay, see, uh, you can say that here is an box. Okay, not box, it's your room. Okay, so this was the cat experiment. Okay, so it is completely closed, and you are standing here outside that room. Okay, and in the room you have two things, uh, radioactive materials, and here is your, you can say, favorite friend, okay, you can say your friend is inside. And here is also a device, okay, which will activate when this there will be the radiations from this radioactive materials, okay. Take it example, it's not a logical or factual, see. And here is a poison, you can say a bottle of poison, okay, glass bottle poison, glass bottle of poison, okay. See, it is like this, okay. And here is device, and device will be activated when there is what radiations from this. You can simply think that when radiations of this radioactive material, radioactive material radioactive material radiations will hit this this device, this will hit then this glass, and this glass will break down, and then poison will spread whole the room, and this your friend will die, okay. Let's say this friend name is B. Now see very carefully, you are standing outside, okay, you do not know what is happening inside. And now there are many conditions. What if radiations leaks, okay, radiations leaks out. When radiations will leaks out, your friend will be dead. But when radiations are not leaking out, your friend is alive, okay. So it means that for you, your friend exists in the two states, because you do not have any connections with the inside, but you know the conditions, that what is the elements which will leads to the consequences. For example, you know the things, that there is radioactive material, there is poisons, okay. When there will be the radiations, you poisons will blast out, and the whole room will filled with that, and your friend will die, okay. You know that what will happen. So you, for you, that friend is in the two states, alive or dead, okay. So these two state, for you this person is in this two state, okay. In the same way, quantum computing works in the superposition. Now let me tell you how this principle is used in the superposition, which will help to solve the many complex problems. For example, you have any let's say xy is a problem. Don't take it like you have their questions in maths to find x and y. No, it's a different thing, okay. See, in quantum mechanics, in quantum computing, superposition means that you have a problem xy, okay. Now, like, you have two possibility of your friends, and for you there is two states of your friend, alive or dead, because you know the circumstances inside. In the same way, quantum computer will know the conditions, that what are the conditions and what are the data given to you, okay. Upon that data, quantum computer will give you multiple states simultaneously. Because of that multiple state, it becomes easy to predict you what will be the answer of it, okay. See guys, for example, x is okay. For example, x is a mathematical state. If the quantum computer analyze the data which is given for the x, okay, there is a maximum possible 100 states, okay. And all the 100 states are observed and analyzed by the quantum computer within second, okay. If it would have been a classical computer, okay, then classical computer have to analyze all the states simultaneously. Like, classical computer will analyze first state, second state, third state, fourth state, like this till the 100. And all the 100 states are analyzed and you can identified by the quantum computer within the second, okay. So it's because of this superposition, okay, that the quantum computer can analyze the more data than the classical computers, okay. And guys, see, it's very interesting. Like, see, for whatever analysis your computer will take the 100 years, okay, that is analyzed within the second by the quantum computers, because I told you it will analyze all the states, existing states, within second. Means that this is a problems, okay, and it will analyze, okay, it can be the answer, this can be answer, this can be answer, this can be answer. Means all the possibility of that thing will be analyzed by the quantum computers within the second. That is called superposition. Means that a particular material can exist in the multiple states simultaneously, okay, and all the states are analyzed, okay, and it give you the complete data, that okay, this much data, this much possibility is there, and all these things, okay. See, and this is used for the astronomical purpose also. how, when you analyze so much states, okay, outside, and this quantum computer, by analyzing or looking at that, will give you multiple possibility, okay, about the life also. See, if you give the supercomputer any mathematical problems or any sample, okay, it will analyze that sample and give you multiple options, which will enhance your understanding and will solve that problem within the second, okay. So that is the beauty of superpositions, okay. Simply meaning that analysis of a particular thing in the multiple state or from multiple angle or corners to get the whole informations within the one go. Okay, if we talk about the classical, for that classical, that will analyze each and every possible state differently and independently, which will take huge time. For example, a particular state, quantum computer and classical computer, there are 15 states, okay, that can happen or possibly be there for a particular thing, okay. Quantum computer will analyze all the things within the 1 second, and classical computer will analyze the different 50 states like this, okay. For one state it will take 2 3 minutes, 2 3 minutes, 2 3, like this till the 50, okay. So here it is very clear that quantum computer will be much more faster than the classical computers, okay. Now let's talk about second fundamental principle of quantum computing, that is quantum entanglement. Quantum, okay, quantum entanglement. See, it means that here is a one thing, okay, and here is another thing, that in this world there are always the two things intrinsically connected with each other, okay. For example, that quantum entanglement means two things are instinctively means they naturally are related with each other, okay, and they have connection within each other, and you can say there is so strong connection between that distance doesn't matter. You can say if a one thing is happening in the earth, okay, second thing, its reaction or its action, or you can say by knowing the things which is in the earth, you can know the things what is happening in the Pluto, Neptune, or in the another galaxy, you can Andromeda galaxy, you can say there is some planet, the thing is happening there, okay. Meaning that quantum entanglement principle says that by knowing the one thing, okay, that is always connected with the second thing, how much distance is between them, that doesn't matter, there will be the trillions of the light years distance whatever between them, okay. By analyzing this one, you can get direct information regarding this one. Now you will say that how it is possible, like I didn't get it, okay. So let me take a very simple example. For example, you went to a shop, okay, and okay, you went to a shop, so you wanted a pair of shoes, okay, pair of shoes. So you get the pair of shoes, two pair of shoes, okay, means one pair of shoes, there is two shoes between that, okay, left and right, okay, two shoes. So you took that box with you to home, but in between the path, okay, what happened, that box was, there was little bit hole in that, okay, one shoes dropped out there, okay. You stayed in a city in between to your home, okay, and where you were sitting, the one shoes dropped there, okay, let's say it was right leg shoes, okay, and you walked with the another shoes to your home, okay, so your home. So now what happened in your home also, your this box in which there was two shoes, okay, one was right and one was left, but right was you can say one shoes of the right leg was dropped in the city where you stayed, okay, in between from shop to house, okay, that was in that city. Let's say this city name is C, okay. Right leg shoes is dropped in the city C, and you bring that box with you. You don't know, you think like that, you do not know that, you are thinking that all the two shoes are in the box, okay, but one shoe of that pair is dropped in the city C where you stayed, okay. So now what happened, this box also got disappeared from your house, okay. Now it got disappeared, it doesn't mean that it got really disappeared, but means that it was lost somewhere, means you was not able to remind where you put that box when you brought that from your shops, okay. And after searching very hard, okay, you came to know that there is no shoes. Okay, you found this box, okay, and there was no shoes, zero shoes, means that left leg shoes is somewhere in the house, okay, but the right leg shoes is in the city C. So now you came to know that यार मेरा एक जूता कहाँ गया. So now you went back where you stayed in the city C, okay, you went to the city C and you found the R, means right leg shoes you found. As you found the right leg shoes, okay, you came to know that yes, if my right leg shoes is here, then definitely my left leg shoes will be there in the house, okay. So it means that by knowing the one thing, for example, if it would be a case that he found only left leg shoes here, so he would automatically come to know that okay, my right leg shoes is missing, okay, meaning that by analyzing or by knowing only one thing, you will come to know about the second thing automatically, okay, that where it is and which type of it is. Same thing is here, guys, in entanglement. By analyzing the one state that is always connected with the second state, okay, means that if we know about this thing, we will know about this thing, okay. It means that it will make our time very easy, otherwise we have to analyze this and this independently, okay. If we analyze this or this independently, it will take us millions of years, but if we analyze it in the minutes and we automatically came to know about the state B, this is the power of quantum computers, okay, and this makes that calculations very easy. Means that you are solving a one questions of mathematics through the quantum computer will solve only one part of the questions, and second part of the question will be related with the one part. And as quantum computer solve the one problem, it will automatically solve or know all things about the second part of the problems, and it will give you the solution within the seconds. This is the beauty of quantum computer, guys, and it is very interesting, okay. See, now let's talk about applications. You have listened that there is some encryption and decryption. For example, this communication, let's talk about. Okay, you have known about encryption, okay, and decryption. See, guys, whenever you are a person here, okay, you send a message to your friend, let's say Rohan here, okay, here you and here is your friend Rohan, and you send him message like we will let's have a dinner tonight, okay. You send him message, let's have dinner tonight, okay. What this is encrypted means there is key to it. Encryption means this message encrypted like 010101 in this way, okay, and this message is encrypted in this way and this is transferred to the Rohan. But in between that there was a person who was very clever, okay. He decrypted your message, means that he when come to know that what was the thing, what is your transferring, means that he know the fixed encryptions of this thing. So he manipulated in between that you and between the Rohan. He came to know that okay, this is the data, okay, they are sending, and he decoded that, okay, he said that oh, let's have a dinner tonight. He, this third person C, came to know that what you are sending to Rohan, okay. And Rohan, the thing, this is the case of classical computing, you can say the classical inscription that we have today's in our phones, in our laptops, okay, through which we communicate with other peoples, okay. And now the thing is that okay, you send the message to Rohan, but you do not know that in between that path, okay, there is person C who is decrypting your message and reading all the informations whatever you are chatting with the Rohan, okay. But the thing in the today's internet, okay, which we use normally, okay, we do not come to know that what is there any manipulations, is there any third person seeking our information between the transfer of our informations, okay, we do not come to know about it. So this is the case of uh, classical that we communication today we use, okay. But if we talk about quantum communications, okay, in quantum communications what we will use, that this is you, okay, and this is Rohan. Okay, you and Rohan. See, this is the thing. Okay, now in the quantum computing or quantum communications, okay, you will send that message in the photons. Photons means these are nothing bundles of the lights. Okay, you will send the message in the photons. Okay, and that will reach to the Rohan that let's have a dinner tonight. Okay, but there is third person C now. Now C also look and sneak into your message that what you are sending. Okay, as the third person will see your message in between that. Okay, the properties of these photon which were sent by you to Rohan, okay, with which that information is encrypted, whatever you want to deliver to the Rohan, okay, that property of the photon will get changed. Okay, message will be changed, but the code of that photon will be changed, will change automatically, because these quantum messaging are very susceptible to the external things. Okay, if anything noise and any interruptions happen, there will be immediately change, okay, with their properties. Photon property will be changed, and Rohan will came to know that okay, there is a person who is sneaking our informations. Okay, okay, okay. What is the difference between first and second case? Now you will be more prepared. Okay, there is someone who is stealing our informations, so now you will encrypt in different way, or you will came to know that. But here you was not even knowing, you are secreting many, you are sharing many secret informations. Okay, so first advantage is this, okay, quantum, that it will make our encryptions and all the things communications very secure. But guys, think, if the people here is using only classical computer, and here people is using quantum computing for the messaging, and here is using classical, by the quantum computer, okay, and quantum communication, it's very easy to decrypt the messages which are sent through the classical communications, okay, which we use today. Okay, why? Because as I told you, quantum, that, what is encryption? Let's understand. Encryption is what? Encryption is nothing, there is a mathematical problems, okay, which is used as a key complex, and for that mathematical problem solutions is from the another person to which you are sending that message. Okay, so if you want to decrypt that, you have to solve this, you must have the key to this problem. Okay, but we know that quantum computers are so fast that they can solve these complex to complex problems within the second. So it will be very dangerous, guys, I am telling you. If this computer quantum computing technology is reach only within the few peoples, okay, they will manipulate, they will, you can say, badly manipulate this classical communication system. They can sneak anywhere, and whatever they want to use, they will do everything means. Okay, so for this we have to maintain the quantum, means it's not that much, you can say, relevant today, but in future it will be, because quantum computer will be at the peak. Okay, and we would know the quantum जो हमारा communications होगा उसको कैसे secure करें, how we can secure that. So it will be the invention in the future. Okay, so it was the communications. Now let's talk about, there will be the research and innovation. Research and innovations. See, as you've seen that in 2024, the Nobel Prize in Chemistry was given for the scientist who decoded the complex to complex protein structure. Okay, by knowing the protein structure, you will come to know that which kind of the disease, how the evolutions happen, which kind of the characteristics come from which proteins, and how kind of properties will be there in the fundamental research. Okay, if we have the quantum computers, okay, we can analyze the complex to complex data within the seconds, and the innovations of the new drugs, new medicines, and you can say the disease which were earlier untreatable, okay, can be become treatable with the quantum mechanics, because the discovery of the medicines and the drugs will be so fast, because the all the informations can be processed within the second, and it will be take very few times for a quantum computer to solve and to analyze the problem and its solution and all these things. Okay, guys, I am telling you that the quantum computers applications are huge, huge, you can say. Okay, it is the future, guys. It is the future of the, you can say, world. Okay, like India is also using that, our national quantum mission is there. Okay, which we are using to promote our Indian, you can say, quantum capabilities. Okay, So guys, this was all about that, how the computer, it will definitely change guys. It will change the human life in the way that has not changed from the last past year. Like internet will be so fast, network will be so fast. It will be like you are at the Pluto, okay, your friend is at the Pluto or Neptune, okay, you are at the in the earth, and you are calling him that hello brother, how are you, and that will be sent within the second. In these days it's very difficult to send the messages or make connections between the objects that are in different planet, okay. It need very big hard you can say infrastructure and investment, all these things. But by the quantum computing it all will become very easy, okay. And it will change our life and everything guys. Research and discovery will be so fast that if the quantum computer is set up in the artificial intelligence, just imagine that what will happen. It will be insane guys. I mean, recently the scientists are very curious to know the things about the quantum computer, but we know that guys, if this goes in the wrong hand, every technology and scientific concept have positive and negative consequences both, so it will also have very bad consequences, okay. In the present time, if we talk about the what's the challenge in the quantum computing, okay, so the challenge is very simple guys. If we talk about the Indian perspective, okay, we do not have that much material, okay, raw material for it which is required. If we have, we do not have the capability to process that material. So like we know that there is a lithium reserve in Jammu Kashmir, but we are unable to extract that. We do not have that technology, okay, to extract all these things. So around 70% of the rare earth elements or critical minerals are processed and you can say mined by the China only, okay, and China is dominating that. So for the computer quantum computing, we need raw material, we need technology, we need more than that human resource. We need such a capable human resource in India, okay. National quantum mission is decided, under which the quantum computing centers are established, okay. The skill development is happening under this. So national quantum mission aim is that we want to make our generations much more capable in terms of the quantum capabilities. Means we, it's a new field and we want to dominate this field. But if we want to dominate, we have to improve our understanding and research and innovation. First is research and innovations, okay, in quantum mechanics, and there would be a scientific view within the people of India, okay, regarding the quantum computing. So this was all about guys. I hope you understand that how the quantum computer works and what will be the applications of quantum computers, okay, and how this will change our future guys. It will change our future that till now we do not have seen the things, that things will be shown by the quantum computing to us, okay, quantum world. Because you are seeing that quantum world is increasing day by day. Quantum world is nothing guys, you are just manipulating the, you can say, subatomic particles, okay. Means quantum means guys small, don't think it is something large, okay. Quantum means the atomic level and lower than atomic level. The properties of the particles are manipulated, okay, they are extracted, their qualities are used for the physical or real life applications, okay. So this was all about guys quantum computing. I hope you got it. Thank you so much.